Hi students, in this video I would like to explain about the basics of random variables and stochastic process and some fundamental concepts of probability. So here I will concentrate on what is sample space, what is an event, what is a trial, and the definition of the probability. So in this video we will discuss about these four concepts. In the next video we will discuss about axioms of probability and proof. So now let us start with the need of probability. So when you are doing one experiment, you have to follow some predefined conditions. So under this predefined conditions, when you are performing one experiment, you have to predict the outcome which is taken as a result. But under these conditions, you may not get the predictable result, or you may get. So that means there is uncertainty. So whenever there is uncertainty, then automatically you will apply probability concept. That means wherever the uncertainty is there, then automatically you should apply probability theory to determine the possible outcome of that experiment. So when you take technically, a basic study of probability is the idea of a physical experiment. So when you are doing one experiment, you need to perform one task for number of times. The task is repeated more number of times. So these number of times is taken as trials. So we have to perform the procedure or the task number of times, and each time is simply called as trial. So you need to perform more number of trials to get exact or more accurate result. So let us take the definition of the experiment. So a test or a procedure carried out under controlled conditions to determine the validity of hypothesis or to make a new discovery. So experiment means you may discover a new thing, or you can able to prove the predictable result under predefined conditions. So in this experiment we have one more thing that is called event. So I will discuss about the event in the next slides. So the very important one is sample space, which is related to experiment. So let us take what is sample space. So when you are doing an experiment, it will produce outcome or result. Now to get exact result for this experiment, you need to repeat this experiment for number of trials. So trial 1, trial 2, trial 3, trial 4, trial 5, like this. And at every time you are going to get one output, output 1, output 2, output 3, output 4, output 5, like this. You need to get number of outputs. So the set of all the outcomes. So outcome output 1, output 2, output 3, output 4, and output 5. The set of all these outcomes is simply called as a sample space, which is represented by S, and all these outputs for every trial indicated by small s, which is taken as S1, S2, S3, S4, and S5. Simply I can write this as capital S is equal to S1, S2, S3, and S5. So this is a sample space. So for every experiment you are going to have multiple number of outputs, and the set of all the outputs is taken as a sample space. And here I am taking one example. So the experiment name is predicting, or I'm simply taking one simple example to understand clearly. Tossing a coin. Tossing a coin. So whenever you toss a coin, the expected outcomes are head or tail only. So these are the possible outcomes. S is equal to H comma T. Okay. So now if you get head as an output, it is one event, and tail as an event, it is one input, one output, or one event. So for this experiment, tossing a coin, S is equal to set of H comma T, the sample space. So this is also called as universal set for this experiment. So for every experiment, S is an universal set. And this sample space is different for different experiments. So for this tossing coin, we have S is equal to H comma T. Now I am taking one more experiment which is called as tossing or performing with dice. So dice means it's look like a rectangular shaped coin which is having 6 faces numbered with 1, 2, 3, 4, 5 and 6. So when you perform with dice, the possible outcome may be 1, 2 or 3 or 4 or 5 or 6. Okay, so the sample space of the dice is 1 to 6. So for every experiment, we are going to have different samples. Now the classifications of sample space. So generally, sample spaces are classified into discrete sample spaces and continuous sample spaces. And again, we have finite discrete sample space, infinite discrete sample space. So let us take one by one. So whenever you have taken one example, so S is equal to 1, 2, 3, 4, 5. So this is one sample space I have. So 1, 2, 3, 4, 5 are outcomes of the experiment. Here I have only countable and finite elements 1, 2, 3, 4, 5. 5 elements, so it is finite. And the elements are discrete only. There is no continuity. 1, 2, 3, 4, 5 discrete values. So automatically I can define this sample space as discrete finite sample space. And there is other one, discrete infinite sample space. So for this I have mentioned one example here. So the experiment name is choose randomly a positive integer. Choose randomly a positive integer. So in the integer set, so you have to select a positive integer only. In the integer set, you need to select a positive integer. So positive integer starts from 1, 2, plus 1, plus 2, plus 3, so on infinity. So here there is no end. It is up to infinity. So this is infinite. Infinite. At the same time, you have 1, 2, 3 countably. So countably infinite elements are there. So this is discrete infinite sample space. Okay. And the other one, continuous sample space. So here I have given you one example of spinning the pointer on a wheel. So I think you may have seen this game in movies also. So on a wooden table, you may have a round wheel marked with number 0 to 12, 0, 1, 2, 3, so on up to 12, and a small ball is going to rotate on the wheel. Okay, so here the sample space is from 0 to 12. The possible outcomes are 0, 1, 2, 3, 4 up to 12. Okay, so this is taken as a continuous finite sample space. Okay, so these are the classifications of discrete and continuous sample spaces. So this is the about classification of sample space. And coming to the next one is event. Simply we can define an event as subset of sample space. Event is always a subset of sample space. I think you know well what is subset. Okay, it can follow completely the sample space and all the characteristics are same as sample space only. Okay, so event is also discrete and continuous. So let us take one example here. So tossing a coin. Example is tossing a coin. So in this experiment, I am taking an event as getting head as an output. Getting head as an output. So you are tossing a coin and you may get head or tail. So the event is getting head as an event. Getting head as an output is taken as one event. So what is the sample space of this experiment, tossing a coin, head or tail? And the event is getting head, so H. So for this, if you are taking one event, getting tail as an event, then E is equal to T. That means here you can simply take E as a subset of S. Okay, and events are classified into discrete or continuous based on sample space you can define. And take an example for discrete event or discrete finite event. So for this I am taking example as playing cards. Example is playing cards. So playing cards 52 in number. So now I am taking event as draw a spade. Experiment name is playing cards and my event name is draw a spade in the 52 cards. So out of 52, the spades are 13. So my event has 13 possible outcomes because there are 13 spades. So you may get 13 times spade as an output while playing cards. So you can define it as 13 of 52 possible outcomes are spades. Okay. So now this is going to be discrete. You can't get continuously 13 spades in the game. So it is going to be discrete and finite because 13 is a finite element. So 13 times you are going to get. And the other examples and other points related to event. So here one other example, select an odd integer in an experiment, randomly select a positive integer. So here experiment is randomly select a positive integer. So in that I am taking event as select odd integer. So positive integers starting from 1 to infinity, 1, 2, 3, so on infinity. In that the event is select an odd integer. Odd integer means only 1, 3, 5, 7, 9, all the things. Okay, this is the output or outcome of the event. Okay, and some few points about events. So event defined on a continuous sample space are usually continuous. Okay, and discrete events may also be definite on continuous sample space, and events defined on a countably infinite sample space do not have to be infinite. So that is very important we need to take, because out of an experiment I can take any event. So select this one, randomly select a positive integer. So in this I can take one event, select on an odd integer up to 11. So that is my event. So I have finite condition here. So automatically you can take for countably infinite sample space, there is no condition to have countably infinite event. Okay. And the next one, the definition of the probability. So generally probability means assigning a non-negative number to the event on the sample space. That is called probability. Assigning a non-negative number for the event on a sample space. So now take examples. I am taking one example, tossing a coin again. So in this example, what are the possible outcomes? Head and tail. So the total possible outcomes are 2. Now I am taking one event. So that event is defined as A. A is equal to getting head as an event, an output. So my event is getting head as an output. So when you observe the sample space S is equal to H comma T. So out of the two outcomes, head has only one chance. So probability of event A, that is which is defined getting head as an output, is number of times the event is occurring divided by total outcomes in the experiment. So number of times head is outcome is 1 and the total outcomes in that experiment is given by 2. So probability of A is equal to 1 by 2. Similarly, take one more example, performing or tossing dice. Tossing a dice. So the possible outcomes in the dice is 1, 2, 3, 4, 5, 6. So now my event is, I am taking event A. Event A is getting 3 as an output. 3 as an output. So in this, probability of A is equal to, so out of 1 to 6, you need to get 3 as an output. So there is only one chance to get 3 as an output. So 1 divided by, what are total outcomes? 6. So probability of getting 3 as an output is 1 by 6. So this is the probability definition. So probability of A is, or if I am taking event as A, the probability of that event is given by number of outcomes favorable to A divided by total number of possible outcomes. So from these examples, you can understand the definition of the probability. Okay, so similarly, we can define probability of an event with relative frequency of an experiment, relative frequency of the event. For example, if you are tossing a coin 5 times, I am tossing a coin 5 times. So the possible outcomes, my experiment is tossing a coin 5 times. So or flipping a coin 5 times. Then here the possible outcomes I am expecting, or I am taking as an example as head, tail, and tail, head, like this. I have the outputs 5 times. I flipped the coin and 5 outcomes are taken like this. So that means you are repeating the experiment 5 times or 10 times or n times. So if you suppose flipped the coin for n times, so what is the probability of getting head as an output? You don't know. So if I am taking probability of getting head as an event, so probability of A is equal to NH, number of times head as an output, divided by total number of times you repeated the experiment, so N. So this is probability of the event. So this is based on number of times you repeated that experiment, which is taken as relative frequency based probability estimation. So thank you for watching. We'll continue in the next video.